So as introduction, what is contour farming? So let's start to define what are contour, right? And the contour are imaginary lines at the same elevation or height in reference to a horizontal plane on the land surface. So contour farming is a soil conservation practice and consists in align our crops following these curved lines that we mark at the same level, okay? As we can see in this slide or in this picture here, we can see those imaginary lines identified in a map, right? For the ones of you that have the experience before that to see a topographical map. So in the topographical map, what we see are those contour lines, right? And they are not other thing, as I mentioned in the past slide. And even you can see it in this top view at the bottom of this image. Those are lines at the same level, right? Is that top view of these two slopes. We can see different lines, but each one identified at the same height, right? Let's say those numbers refers to meters. So at 10 meters, 20 meters, 30 meters, 40 meters, right? So those are those how we can see those imaginary lines in a draw, right? But in the aspect of in farm, those lines looks like this plot here. So this plot here is in one farm that is part of our food producer network program. So and all the plots there are farming in contour using the contour technique, right? So this is how those lines look in the field. This is a really small plot, right? So in the next slides, we will be seeing this in more broad area. As recap, some of the benefits of the contour farming is that they help to control and prevent soil erosion, improve water infiltration and retention, and let me stop here and make a parenthesis here and go a little deeper in some of those bullets, right? For example, in the first bullet, it say that contour helps and prevents the soil erosion, right? So soil erosion, it's a big or really important topic in farming, right? Especially in more industrial farming, right? So we are depleting our soil for the past decades, right? And today, soil is a really we can consider soil as a non-renewable resource, right? Soil, it's in the constant state of development, but it takes so long that in our lifespan of in our human lifespans, it will take several generations to see the complete cycle of the soil development, right? So for that reason, we need to protect our soil. As I always say, and for the ones that has been before with us and in the webinars I teach, I always make an emphasis in how important it's to protect and to enhance our soil, because the key for a good or a really productive and really well agriculture relies on the soil health, right? So it is really important for us to protect and enhance our soil, right? And one of the things that we need to do is to protect the soil against erosion. Contour farming helps in a really significant way to prevent soil erosion, but it is not the only tool that we can use. We need to integrate many other practices to protect our soil from erosion. And as I mentioned, the first defense line from soil erosion, it's to have our soil covered, right? Even if it's covered with the spontaneous vegetation that we have there, that sometimes we need, we tend to relate it with weeds that they are not desirable there, but it is the first line. So bare soils are not a good thing, right? Bare soils are more prone to erosion, right? So first barrier against the erosion, it's to keep all the time our soil cover, right? In terms of the impact of contour farming in the water infiltration and retention, it is because, as we can see around the globe, the effects of the climate change are drought seasons that last longer, right? And in the other hand, sometimes we see rainfall events that are more significant than the year before, right? So we need to storage that water in the best way. And one of the most successful and useful water storage is the soil, right? And the infiltration for the subsoil and the aquifers bodies, right? So one thing that we need to do is manage our soils that can storage the good amount of water and retain that water there for several times, right? It's more effective and cheaper than just be buying or doing some construction for water storage, right? Other benefit of this is that contour farming facilitate traction in the steppe of planting areas for the ones that are living in places like where I live in Puerto Rico, that we have a really amount of mountains that or our surface area, the most part of our surface area are steppes. We know very well how hard sometimes it is to work in the farms in the hills, right? So contour farming allowed us to have a better traction and to make more easy the labor of day-to-day in farms, especially in the mountain regions, right? It's restore and improve soil fertility, because plus that the soil, we are keeping our soil inside. More than this, we are helping to retain other kind of material as organic matter, right? And when we retain our organic matter in our soil, that promotes to have there the complete cycle of organic matter. And organic matter is really, really important for our soil fertility and many other good things in our soil, right? And when we're talking about soil fertility, it's not part of this topic, but I need to mention it. When we are talking about soil fertility, we need to look the fertility of the soil, not just in the chemical way, but in the physical and biological aspects too, right? Soil fertility have those three components, right? Chemical, physical, and biological. And for the ones of you that want to learn a little more about this, you can visit our platform online and see our webinars on soil on soil science, right? There we have some basic soil webinars and advanced soil science webinars there too, right? Other benefit is that they allow and or facilitate the use of tools and other technologies on the slopes. For example, I don't know how many of you are familiar with the two-wheel tractors, right? Or the walk-behind tractors, for mention some of those machinery that in other ways it's impossible to use in the slopes, right? So when we are doing contour farming, we are making easier our work on farms. And one aspect of this is that it's allowed better traction to use other technologies in the slopes, right? Causing minimal or non-detrimental effects on our lands, okay? And to the last, combined with other soil conservation practices, all of these advantages are maximized, because soil conservation is an integration of many other practices, not just using one. But if you are just using one, you are in advance, right? So no matter how many of them you have, even if you are starting with one, you are in advance to other producers that are not implementing any of those practices, okay? Before move on to the next slide that we're going to enter now in what is our main topic today, there's any question about what is contour farming, what is contour lines. Sometimes it's called, contour lines are also often called contour stripes too, right? So there's any question?
There's nothing in the Q&A, and just a reminder to everyone, thank you so much for telling us where you're connecting from today in the chat. And if you have any questions throughout, go and click that Q&A button, and you can send your questions right to us, and Juarez will answer them during the webinar.
Thank you, Jesse. Okay, well, let's go to what we come here today, right? Or came here today. So there's significant tools that we can use to trace the contour in our lands, right? There's really advanced technology tools like the ones that we have here. For example, at the left of your screen, you can see what is called a telescope level or dumpy level. It's more common name as this way, as a dumpy level. And at the right, you have a clinometer, which is both are tools that are often used to identify and mark or trace those contour lines in the plots. But those tools are not so accessible to everyone, right? Because of the cost, because of sometimes they're not any supplier near your region or whatever the case is, and they are really useful, but they are not so accessible to everyone, right? That's the reason why.
Can you repeat the names of the two devices?
Okay.
Screen?
Oh, okay, so the most common name for this apparatus at the left of the screen, it's a dumpy level. It's the common name, right? But most formal name, it's a telescope level 2. This has been in use for several years, right? Especially the surveyors often use this kind of tool, right? Nowadays, or for the at least in the past decades, you can find some in the markets that are automatic levels that use laser technology, and you just need one person to operate in the field. But the cost of those tools are kind of expensive, right? A good one of this kind, not laser one, as this one, it could be ranging a good one, right? For around $500 or $2,000. The clinometer have many other uses, right? Even to measure the height of the palm trees, etc., right? And the cost of a good one range from around $200, right? But today we will be learning how to build our own tools for less than $20, okay? And those tools are as useful and as those technologies, okay? One of those tools, and one of the most common tools or handmade tools to trace the contour, it's this one. Many of you probably has seen before. This is the A-frame or the A-figure level, right? And it's really easy to make. This picture is from a farm in Puerto Rico, from our friends of TechnoServe and their program Revivamos el Café. That is a program towards the revitalization of the coffee industry. They keep working in Puerto Rico, but they started that program a year after the hit of the Hurricane María. In 2018 is when they started working, and they has been promoting conservation practices among the coffee farmers. And this technology has been around for several years, even we can say for 100 to 1,000 years, right? Because tools as this one and the next one I will show are the tools that probably were used to build the ancient roads, bridges, even places like Machu Picchu and other ancestral places. So those are ancestral tools, and even the base of those concept of conservation practices in soil, what many of the things that we call nowadays regenerative agriculture is the more trending name, are practices that has been employed by the farmers for many generations, right? We can say it is ancestral knowledge, and it's thanks to the many for the smallholder farmers and the peasants are alive today and gaining popularity among the producers, right? So those are the one of the types of the tools that we can build by our own, using wood, using PVC, or even using some wood from the farm, right? The other one, it's what is called the ISO, or the end frame level, right? So this one that you see here is not such as popular as the A-frame, but I met this tool like around like 8 years, I think 7 to 8 years ago, and since I changed to use the A-frame to the end frame or the ISO, because for me it's more effective in the field to use this kind of tool. It's that's depend of your preference, right? But for me, this is in my case, I'm more efficient working with this tool than the A-frame, right? Both are really useful, okay? And as I always mention when I talk about those tools, as when I was on grad school, I like 2 or 3 times I had the opportunity to be on a field making some tests about how those tools correlate with more advanced tools as the dumpy level, and if you build well those tools, the difference is barely nothing, right? Maybe point something or 1%, okay? So those are really useful tools, okay? So both A-frame and the ISO or N frame are not other thing that levels for the soils, okay? Today, I will be talking a little further about the ISO of the N frame, and this tool have 3 components, right? First one is the horizontal piece that we use here, that we call this the bridge, okay? The other thing, and one of them, or the main component of this tool, is the bubble level that we use there, and the other things are the legs, okay? How what are the measures for this tool? So the measurements will depends of the use that you're gonna make, or the work that you're gonna make with this tool, or as I build my ones, about your physical characteristics, right? How tall you are, and your capacity to work in field, right? Both A-frame and the ISO could be built, as I mentioned, in wood or in PVC, okay? In my case, I prefer to build my ISOs in PVC because of the weight, because of the cost, because how they last, okay? So that will depend what you have. Sometimes you can reuse or recycle other materials. Some people build it even in using steel. But in the case that you gonna build it, use it wood or PVC, that is what you need, right? So in the case you want to build it in wood, you will need what it's commonly named as dimensional lumber, by 3 inches. In the case of PVC, you will need PVC pipes from about 1.5 or 2 inches diameter pipes, right? In my case, and in my experience, I built my ISOs using PVC of 1.5 inches in diameter, because they are more lighter, right? And not so expensive, right? I built my ISOs for less than 20 bucks, okay? In case you decide to go with the lumber ones, they are useful as well too, right? Other things that you will need to build this kind of tool are, in the case that you are using PVC, you will need two 90-degree elbows and glue for and PVC for a glue, okay? Other things that you may use are a screw, and again, above all level, that is the central component of this tool. Tape or any other equivalent material as straps, as whatever make the work to attach that bubble to the bridge of the ice, okay? In the kind of the measures, in my case, I built mine once in a length of the bridge about the length of 2 meters and the legs around 90 centimeters of height, because that's the perfect height for me, because I'm around 5'10", 5'11" tall. So it's what works for me and helps me to prevent to have any injury or keep to protect my physical health, right? Because in the field and as a farmer, the work is really hard, and we want to be working as long as possible, right? So we need to customize our tools in relation to our physical capacities. Okay, so that's my measures. But if you are taller or stronger than I, you can adjust those measurements to your physical characteristics, as I mentioned, right? Other thing that I want to recommend, I do not recommend to make this the bridge in length above the 10 feet, because sometimes the precision of the tool could be affected. Okay. Other thing is, if you are using this tool to plot or to mark lines for crop rows, in the case that you are planting trees, shrubs, or perennials crops, you can make the bridge in the length of the bridge as the same planting distance of each of those trees or shrubs or whatever you are planting. For example, if you are planting oranges or lemons, for example, in the field, and the separation between each tree is about, let's say, 5 feet, you can build the bridge from 5 feet, and at the same time that you are tracing your contour line, you are marking as well each of the areas that the holes for each tree will be, right? So you're making two tasks at the same time, right? So the length will depend, as I mentioned, on your physical and the purposes, your physical capabilities and the purpose that you will use it, right? If you are just using to mark lines, for me, the most effective length, as I mentioned, is 2 meters of length. Okay. So there's any question about the materials or the construction of those tools?
There are no questions regarding the tools or materials yet.
Yeah, thank you, Jesse. Other thing is, and before I transition to the next slide, if you are building this tool using lumber, you can use a screw with what it's named butterfly nuts that help you to detach the parts really quick and to a storage and make easier the storage. even if you're building on PVC, what I do when I construct, when I build my ISOs, I attach the legs to the bridge using a screw, because that will help me to detach the legs. It's easier to transport and easier to storage too, okay? So now I will, we will see this video where it's explained how to use the A-frame, but the concept and the way that we use the A-frame is the same way that we use the ISO. This is the same concept, okay? And both are used in the same way, okay? So let see this video. At the end of the video, we can discuss any question that pop up, okay?
A-frame that I built. I'm trying to figure out the contour lines on the property. Until you actually do this, you're guessing. And then when you have an instrument, a measuring device, then you're not guessing anymore. So the features of this one are that I use materials. If I were to disassemble this, I could use all the materials. No materials were damaged in the making of this A-frame. You see it has the 3-foot level, 2-foot level. There, got the beer holder and a rod holder, stake holder, so that everything's close at hand. I'm reminded of the fact that I'll probably have a walker someday, and you see people walking around with bags and canes and stuff all over their walker. And yeah, so this thing's a little bit heavy as an A-frame goes, but you only have to move it 5 feet at a time. That's the distance from the 2 legs closest to us here, 5 feet. So it only moves 5 feet at a time. And it also has enough weight where it sits down into the earth and through the grass, so it doesn't float. And I put a kickstand on it, so even though it's heavy, I don't have to lay it down, pick it up, lay it down, pick it up. It's I move it, I put the kickstand down, I sink my steak, take a sip of beer, and that's how it works. It may or may not look it, but all of these stakes here are at the same, the bottoms of them, not the tops. The bottoms are all at the same elevation. And they go out this way and that way. And then here's a second line. These stakes here are 18 inches below the first row of stakes. 18-inch difference from the one in the back to the one in the foreground here. And that will be, all this will be terraced because we have way too much water that runs off the property into the street. It's damaging the street. We're losing the water. So we're going to change that. We're going to put terraces on here and see how that works.
All right. So there's any question about the use of the ISO or the A-frame in this case? As we see here, this is A-frame with more advanced features like you know the beer holder, but you also can just use it for hold your bottle of water or whatever you want to drink during the work, right? We are not recommending to use alcoholic beverage during the work, but this is up to you, right? Anyway, so that's the best video I can find online that explain this in a simple way, right? So before we end, I will share in the link of the video through the chat, okay? So as you see, it's really simple. You just need the tool and the stakes to mark the points of the lines across the slope, okay? Jesse, there's any question?
We are good to go. Thanks, Wadis.
Okay. Now I will be giving some tips when for a better line tracing on field, right? So let's imagine that this is our field that we want to trace our contour line, and there's nothing here, just us looking that slope, right? This is not necessary to make it to make to done the line tracing right, but it is good to start, or that will help you to do the work most efficient, right? So the first thing that you need to do is to determine the area of the slope that you want to work, okay? That you want to cover. And let's say the top point of this area is this one here, okay? So the first thing that you're gonna do is to mark that point with a stake, with a flag, with anything that you have able, right? So you mark this first point at the top, and then you will mark a point aligned with this one. You can use a rope or sometimes any other thing that you have able, right? So you will align another point at the bottom of the slope, right? At the tip. So the other thing, next thing that you're gonna do, it's go to the middle between those points and make another point there, right? So right now we have marked what we call as, or what we can call the master line, okay? So that line runs from the top to the bottom of the slope, and that will help us to mark our first line that we will use as a guide to mark the other lines, okay? But the considerations that we need to have before do this, it's that the slope in the area have the same decline degree across the section that we want to work, right? But let's say, for example, we want to work all this area, and this slope here have a higher percentage than the one here, right? So what we're gonna do is to separate that area in two plots, right? Because the degree of the slope will affect the effectiveness of our contour lines tracing, okay? So we need to do this in areas that are really alike. If the slope are almost the same degree of decline, if we have high, if that's vary in a higher degree, so we just divide and do each plots like a separate plot, okay? But let's go back and say all this area have the same degree of decline, okay?
What is, if I can interject for one moment, I believe you've spoken about this in the beginning, but Dominic asked the question, what the use of the level is. And so I just want to make sure that that you can clarify between, as one is moving their easel across the line, how the level comes into play.
Yeah. I will be explaining this soon in this slide, okay?
Perfect, thank you.
Thank you, Jesse. So we have those points marked, right? And we will start to mark our level or contour line right now in this at the center, right? Let's say that's the center of line to use our friend there, okay? So what we do is that we put and we start for the first point at the center, for the first mark that we put at the center of that line. We can move to the right or to the left. It's up to you, okay? So what we do with the tool is that we put one leg of the level in that point, and we start to move the other leg. With this one steady, we start to move that leg of the tool, searching for half our bubble level or at the center, right? That implies that our level there, it's 0 degree of slope, okay? So that's the use of the level. It is the same principle as when we are using what we call spirit level in construction, or to place anything at level. It is the same principle, okay? So we will be moving this level at one leg of the level, looking for level 0, okay? And when we find it, we put the next point, or the next stake there, because that point are in a level of 0 degree of decline in reference to this point, right? And we keep doing this, so on, until until the length that we determine, it is where we want to go with our contour lines, okay? It's really is simple as this, okay? I don't know if I answered the question, but that's the use of the tool, right? Even for this level, or for the easel, or for the A-frame, okay?
I believe so. If the questions come back up, we would encourage everyone to continue to write us in the Q&A. But thanks, Juarez.
Yeah, so that's so simple to mark the contour in our lands, okay? Simple as this. The other thing or considerations that you may have when you are doing this is sometimes we have some things on the soil that are really specific in this site, or in situ, that maybe we find some rocks that are there, or any depression there that is not regular, right, across the line. And that's sometimes it's kind of tricky, especially when you are starting to work with those tools and making contour lines. And some of those points at the end will look really outside of the line. So that's no problem. What you need to do is just to fix this by moving your point as possible aligned with the other ones. That will not affect any of the contour in your land, right? So we want to do this as better as possible, but knowing that in the nature things are not so standard, right? So having this in mind, just you just feel free to sometimes to arrange those points to keep the line as more aligned as possible through all the points, okay? Let's see. So yeah, I think that's the basics and the principles and the basic considerations that we need to have when we are using those tools in the field, okay? At the end of our work, and let me add something, right? If the surface and the slope is pretty the same across that section you are working, sometimes what you just want to do is to mark that line that serves as a guide line, and then you can align the other ones points or stakes or flags, or whatever you are using to identify those points, just by using this line as a reference. You don't need to use the level to mark all the lines across the section that you are working on. You can do it, right? In my case, sometimes I want to be specific as possible, so I'm the ones that all the time I'm use this the tool to mark all the lines across the section. But other consideration that you need to have in mind, it's if you are tracing the contour lines before because you want to tilt the area, you need to make this before to tilt. But when you are after till the soil, it's barely it is virtually impossible to use this any level that any level would be effective there, because the surface will be really raw and we will never find the right level, right? So before till, you need to mark your contour lines. Well, let me show this, okay? For example, after we mark our lines, we can do our beds, planting beds or rice beds, as these are they're called too, in the field, right? So this is the result of that work, right? In the case of this farm, they plow the soil using oxens, right? So what they do is they mark lines that serve as a guide across the field, and as you see here, all the curves here have the same shape. So before they plow, they mark those lines, they plow, and they build the rice beds using as a reference the contour that they identified before, right? That is one of the cases that they are not marking all the lines using the tool. In this case, they use the easel. But if you are doing for other purposes, as we gonna see now, because it's not just for make beds or crop rows or this kind of practices, contour lines have several uses, right? For example, when we are implementing other erosion control technique as this one, as vegetative barriers, we can use those tools too, right? As you can see here, it's a curved line that marks the contour of this area where they use the contour farming to implement this practice, okay? Other thing that those tools are useful, it's to mark the contour to establish these other practices, which is our stone bonds that are really useful against soil erosion too, and to make some terraces for plantings in really in areas with really high slopes, okay? Other use for contour farming and those tools are that it's a really helpful or it's a basic tool that help us to implement ditches systems for the water, for the discharge of the runoff water, right? So it is really important when we are talking about soil erosion control to manage our water, right? To don't allow water to run free through the field, right? Each barrier, each contour line, each crop line, or whatever we are implementing to the contour in the field, it's helping us to break the speed of the water from point A to point B, okay? And the speed of water, if we allow water to run free through the slope, from this point to this one, water are gaining across the slope a lot of speeds, and that's increase the erosion potential of the water, right? So ditch systems are really recommended to manage water in the right way, and even to promote the infiltration of the water, right? So ditch systems are other practice that I all the time recommend to the farmers that are farming in the slopes, right? So for this, talking about the water management of the water, the right discharge of runoff water. So we want our water, most of the water that could be infiltrated in our soil is good, but sometimes we have excess of water, and we want to discharge that excess of water out of our fields, but in the right way, right? So in this case, our contour lines, we don't have to be to be at level 0, because at level 0, water will not run from any side, right? Water will stay inside, okay? So for discharge of water, it's highly recommended to give some slope to our lines or to our ditches, right? The degree of the slope will depend of the characteristic of your soil, the climate patterns in the region you are, but an average percent of slope recommended to give to put in our ditches range between 1% to 2%. Okay, so we sometimes want to give like a 2% of the slope in our ditches, right? And also we can make this using those tools. We can mark those lines with this percentage of a slope using those tools and just doing the next steps that are really simple as the all others that we has been discussing. Okay, if we want to adjust our tool to give that slope percentage, the only thing that we want to do, we need to do, it's to make one leg of the tool shorter, right? And for this, to determine how shorter that leg should be, we do the simple next mathematical exercise, right? Let's say our bridge in the easel or the bridge in the middle of the A-frame have a length of 200 centimeters, right? Or 2 meters. So I converted and use it in centimeters because for it's more convenient in terms that to have a whole number that just fraction numbers, and it's more useful in practical terms, right? So let's say we want to, in my case, for example, when I build or doing some slope through my contour lines or building dishes, I often use an average or 2% of a slope. Okay, so let's say that our bridge, because this adjustment, it's in relation. What we use is the length in relation of the height of the tool, right? So having this in mind, so let's say that our bridge have a length of 200 centimeters, right? And we desire a slope of 2%. Okay. First that we're gonna do it's to convert that percentage to a whole number. Okay, so really easy, just divide 2% by 100, and we have that the whole number for this is 0.02. Okay, our bridge have a length of 200 centimeters, so let's multiply 200 by 0.02. Okay, the result it's 4 centimeters. Okay, so that implies, or therefore our leg should be one of the leg of the tool should be 4 centimeters shorter than the other one, right? In my case, my easel have the legs have a height of 9 centimeters, which implies that I need to cut from the other one 4 centimeters, that equals to 86 centimeters, right? So one of my legs in my tool will be 90 and the other one will be 86, right? When we are doing this, let me go back here to make more visual. When we are doing this on the field, how we trace that line, it's to use the highest leg in front, okay? The leg that you will be moving to identify that level in the field will be the high one, okay? That will be the front leg, and the shorter leg will be the back, okay? So, and it's in the way that water will run in the field, okay? For the ones that use the English measurement system as we do in Puerto Rico, let me say that an inch equals to 2.54 centimeters. Okay, so you will divide, if you want to change these to those measures to inches, you just need to divide centimeters by 2 centimeters by 2.54, and we do have the results in inches. Okay. Is there's any question about how to adjust those tools to give slopes in our lines? And let me say, by the way, I know this before for the use of the easel, because I've been using the easel for longer than I used the A-frame. But yesterday I learned from one of our participants that the same thing you do on the easel on the A-frame to give to make that adjustment and have that slope in the lines. Okay, it is the same thing that you do even in the easel and in the A-frame. You make the adjustment just by doing this. Okay. Yes, if there's any question yet.
I believe we're good, Juarez.
Okay. Okay, so let's say this is our tool with that adjustment that will imply, as I mentioned, this leg will be longer than this other one. And that's the other reason that I attach the legs of my tools using a screw, because when I build those tools, I make two legs of the same height to have a level of 0 degrees, and other leg with around 2 to 2.5% of slope, and I do a shorter leg. So my tools all the time I build it with 3 legs, right? 2 from the same level and 1 shorter to give that level of slope in the fields. And I use screws because are really more easy to change it. Okay.
What is we do have a question regarding this topic. The question is, how do you determine the elevation of the line and plot to the next line at 10 feet or higher? This is from Russell Patterson, who says, how do you determine if the line is 300 feet and the next line is at 310 feet?
Okay, that's a good question, and that's and completely other topic that we can make just a webinar talking about this. But for example, let me go back to this, and thanks for the question, right? We determine where our lines, the distance between our lines as we want, right? For example, if we are doing rows to planting crops, it would be the recommended distance between crops, right? But when we are measure distance in the slopes, that have the trick, right? Because okay, Jesse, we are live, and I want to share the most information as possible. Okay, so just let me switch what I'm projecting. I will stop share this, and I will pop up another presentation that I have that it was made by the Natural Resources Conservation Service, or NRCS, from USDA, right? And I know the author of that presentation, and we have the permit, and it is for the public use, right? That's the reason why I will be popping up this presentation. Okay, let me reshare my screen. Okay, here we are. Okay, let's find this. Okay, as I mentioned, for row crops, that will depend on the distance between each line, so that it's really specific for each crop, right? For in the case that we are using those lines to trace erosion control barriers, let's say, or ditches, right? As the higher of the slope degree, the lines will looks that they are more closer, right? Because we determine that distance in function of the depth, right? For example, as let me find this here. As we can see here, the contour intervals of contour map is difference in elevation between successive contour lines, right? For example, for soil erosion control, contour lines are drawn at fixed vertical interval of 1 meter in soils with more than 15% of steepness, right? For soils that are under that 50%, the horizontal distance in function of depth will be 0.75 meters, right? So the way we measure this, that will depend, as you can see here, of the degree of the slope, right? And have its tricks, but they are another tools that could be handmade and are really useful for that, right? I don't want to enter so much in this because I think that yes, that could be another topic within erosion or erosion control practices webinar. We are working in develop more curriculum about those practices. So, but I just want to show the tool that it's used for that, right? And it's this one. It's what we call the T-stick, right? And the T-stick use a bubble level and could be, as you see here, built from lumber or even for PVC, as I made my ones too. And you use this to measure that distance, okay, in the field, right? For example, what we do is we identified our first point and how far will be the next one in function of 1 meter of distance. What we do is that we look through that through this area. It's we can say it have an objective here. So we can we employ here too a bubble level, and when you see in the reference of when we see the foot of our first stake or flag, as you see here, and the bubble level, it's at level 0 here, that's implied that we have a meter of distance here in function of depth, right? That's I don't want to go deeper in this because I have other mathematical aspects that to make this, right? But it is really easy to use, and the thing that it's work more than the bubble level, it's that the height of the instrument is 1 meter. For example, in areas that we have a slope higher than 15%. In the case that we are working in areas less than 15%, the height of this tool will be 0.75 meters, right? But this is a whole other topic, right? But the question, it's a really good one. So thanks for asking, right?
And what is, if I'm not mistaken, this is something that you discussed during the sustainable soil management webinar, is it not?
Yeah, I think
I remember this exact artwork. So what I would recommend to anyone who's really interested in the topic, as we have put in the information in the chat, there is, you can sign up for our education portal, where Juarez gave an entire phenomenal webinar on sustainable soil management, in which he discusses a lot of those very topics in more depth. So that would be my recommendation, while he and I are always talking about more topics that we can discuss and share with our audience. That would be a great next step for you.
Yeah. I totally agree with Jesse. We have several, not just in soil conservation practices, but we have a huge inventory of webinars in our platform, and we invite everyone to get as much out from there, right? The other thing is, at the end of this, I will be sharing my email, and from the ones that are interested in know a little more of this, I can send the presentation from NRCS. I can email that presentation to anyone that are interested in to have it and understand a little more of those techniques, right? Okay, so let me go back here. So that's the way that we, as I mentioned, that we give we make that just of the tool to give that slope in our contour lines, right? Really useful too. And I mentioned a slope of around 2%. It's an average, but there are some equations that you enter the type of soil, the amount of rainwater that you received in an interval of time, etc., other characteristics, and that give you the exactly slope that your soil could manage before it start to eroding. Okay, but that's another topic too, and the reason is that information is not able for everyone, so that's the reason I recommend from 1 to 2%, no more than this, on your soil, right? At the end of all of that, we are entering in the last part of our webinar today. So this is the product of the contour farming, of use those techniques. So this is this farm for the ones who was with us in the reply or the first time we did the contour farming 1.0. That's the same farm that we used as example in that webinar, but now the farm has been growing, and if you see here, all the farm, it's doing all the work there. It's through the contour farming, right? And you can see here different type of lines or contour strips, right? Because this farm have different slopes levels or types of slopes across the farm, right? So that's the reason why you see there the different contour lines, right? So this is a good example of how contour farming looks. Okay, it's really helpful for me. Needs to be a standard practice in any land or farmland that are above the 5% of slope. Okay, just want to add this again. I mentioned at the beginning of this, but I just want to say, oh, my bad. Jesse, that same as yesterday, I forgot to play the video of the ditches conducting water. Okay, so let's see. The video is from this farm too. I just want to show to all of you this. Okay, let me pull out of the video. It's for you to see the water in motion when we implement that practice of the ditches with slope. In this case, in this farm, the farmer used a 3%, but because they know the soil can handle that kind of slope. Okay, so let me pull up the video and show it again. So let me find it. Okay, so we're here. Okay. Okay, Jesse, the video was able to see it.
Perfect.
Nice. So there you can see the run of water moving through the field there, and at the end of those lines or those ditches, right? You see they were the natural the spontaneous vegetation of that area, and the farmer don't touch that area because that's the natural path of the water in the field, right? So he's conducting the water to the natural path of water to more a really effective water discharge in the farm, right? So that's the you just see it in action, how dishes with slope work. Okay, so that's the same farm. That's how contour farming looks in field. That will vary between farm to farm. Sometimes looks really all the contour lines look in the same shape. That will depend of the topography of the area, right? Last thing I want to recap, it's that the effective erosion control is achieved by integrating multiple practices, right? As we can see here in this draw, this draw is from Honduras document I find online. It's kind of old, but it's really good because here we can see many of those erosion control practices in field, right? Like we have ditches here, we have vegetative erosion barriers. Other thing, we have individual terraces for planting, and everything of each of these practices. Even if you can see here, we can see that the soil is not a bare soil, right? So as I mentioned at the beginning, soil protection is really important. Practices against erosion is really important. But we need to integrate all those practices, right? And the other thing that I find nice of this is that this document was done in reference of many of the practices that the peasants farmers or smallholder farmers has been using from decades or centuries in that country, right? And it's almost the same. For example, when I was gaining interest in agriculture, and several years ago when I was an undergraduate student, one of the first experiences I had doing any conservation practices, it was in a coffee farm. And I was really excited because I learned something new for me. By that time, I believed that no one in my families or the recent generation were dedicated to the farm. But in that afternoon, I was visiting my grandparents' house and my grandmother. When I was really excited, telling her about what I learned that day to do that individual terraces, to planting coffee trees on the farm. She told me that that's the way that her father, my great-grandfather, did, because she had the opportunity to live her first years of her life, of her 10th or 12th years in a coffee farm here in Puerto Rico. And I realized by that time that there's nothing new. Are good techniques that we abandoned at some point, especially for the promotion of more industrial agriculture. And the other thing is that just 2 generations ago, my family were dedicated to farming, right? So that's good for me. Anyway, quick history that I want to make. So anyway, main message or my main the main purpose of this today, it's to promote those practices and to show that with just a little money and a little time, we can implement those practices in our farm, and they are really, really useful, right? So again, use more or implement or integrate much more as possible for you of those practices, okay?